Good evening, children.
Good evening, ma'am.
Good evening. Good evening,
Good
children.
evening, ma'am.
Good evening. So we started this chapter circles in the last class, and we did have the introduction to this chapter regarding the basic terms used in this chapter. These are the notes for the chapter, children. Please take screenshots. This is the first one. Please take a screenshot. What is meant by a circle? What is the radius of a circle? What is the center of a circle? Done, children?
Yes, ma'am.
Okay. And this one is read as circle with center O and radius R. Circle with center O and radius R. So see here is a circle with center O and radius R. So see here, a circle with center O and radius R is denoted by circle with center O and radius R. This is circle with center O, not 0, center O and radius R. So supposing we have a circle with center P and radius X, center P and radius X, then we say circle with center P and radius X. Circle with center P and radius X. So here we have the definitions of the term radius and circumference. Done, children? Taken a screenshot?
Yes, ma'am.
All right. This is the third one. What is a chord?
Ma'am, 1 minute last date, ma'am.
Sure.
Yes, ma'am. Thank you.
Done, children?
Yes, ma'am.
Oh. This is the fourth one. What is meant by the term diameter? Secant. Tangent. Position of a point with respect to a circle. If it lies inside the circle, then the line segment is less than the radius. We discussed all this, children. All the slides which we have seen so far, the terms were discussed already in the class, in the last class.
So should we write all this after the class in our notebook?
See, given that it is time consuming, it depends on, the time available at your disposal. If you feel you have the time to write all this, you can write. Otherwise, give it a good reading.
Okay, ma'am.
Yeah. I think if you read it once or twice, that's sufficient. But I'm not saying you don't have to write. Yeah, so I don't mean to say that you don't have to write it. If you feel you have the time, you might need about 2 hours to complete this with the figures. I think a good reading will do.
Okay, ma'am.
Yeah. Then we also understood that a circle divides the plane in which it lies into 3 parts: interior of the circle itself, and the exterior of the circle. The circle divides the plane on which it lies into 3 parts: interior of the circle itself, and the exterior of the circle. Arc. What is meant by an arc of a circle? It's a part of the circumference of the circle or a continuous piece of the circle. A continuous piece of the circle is an arc of a circle. Semicircle. These are the 3 different arcs which you can find in a circle: semicircle, minor arc, major arc. These are the 3 different types of arcs you find in a circle: semicircle, minor arc, major arc. Segment of a circle. The region bounded by a chord and an arc. Minor segment, major segment.
Ma'am, can you show the previous slide, please?
Yeah, sure.
Thank you, ma'am.
Yeah. Minor and major segment. So here alternate segments of a circle. Alternate segments of a circle. The minor and the major segments of a circle are called the alternate segments of the circle. The minor and the major segments of a circle are called the alternate segments of the circle. Sector, minor sector, major sector. Semicircular region, where both the segment, so you can, semicircular region, we understood that it can be called a sector as well as a segment. When a part of the circular region is both a sector and a segment, it's called a semicircular region. I think cyclic quadrilateral we did not discuss. So from here we have to continue. So if you have a quadrilateral, and if you can draw a circle passing through all the four vertices of the quadrilateral, then the quadrilateral is said to be a cyclic quadrilateral. You have a quadrilateral. You have a quadrilateral. If you can draw a circle, passing through all the four vertices of the quadrilateral, then the quadrilateral is said to be a cyclic quadrilateral. You have a quadrilateral. If you can draw a circle, passing through all the four vertices, of the quadrilateral, then the quadrilateral is said to be a cyclic quadrilateral. So you can see the figure ABCD is a cyclic. ABCD is a quadrilateral. ABCD is a quadrilateral. It is a cyclic quadrilateral because we can see that the vertices A, B, C, and D of the quadrilateral lie on the circumference of a circle or lie on a circle. You can see A, B, C, D, all these 4 points, all these 4 vertices of the quadrilateral lying on a circle, lying on the same circle. So that means we are able to draw a circle. Passing through the 4 vertices A, B, C, and D. So the quadrilateral ABCD is said to be a cyclic quadrilateral. A quadrilateral is said to be a cyclic quadrilateral if you can draw a circle passing through all the 4 vertices. All the 4 vertices. Now the points A, B, C, D. The points A, B, C, D are the 4 vertices of the quadrilateral. But now since the quadrilateral is here in this figure, ABCD is a cyclic quadrilateral. The points A, B, C, and D are said to be concyclic because they are the vertices of a cyclic quadrilateral. Because A, B, C, D are the vertices of a cyclic quadrilateral, the points are said to be concyclic. Concyclic. Properties of a cyclic quadrilateral: opposite angles are supplementary. In a cyclic quadrilateral, opposite angles are supplementary. So angle A plus angle C is equal to 180. Angle D plus angle B is equal to 180. In a cyclic quadrilateral, opposite angles are supplementary. The sum of these 2 angles is equal to 180 degrees. The sum of these 2 angles is equal to 180 degrees. In a cyclic quadrilateral, opposite angles are supplementary. They add up to 180 degrees. They need not be equal. They add up to 180. If you produce any one side of the quadrilateral, supposing you produce this side, When a side of the quadrilateral is produced, an exterior angle is formed. When a side of the quadrilateral is produced, now here the side AB of the quadrilateral ABCD is produced. So when a side is produced, an exterior angle is formed. Now the measure of this exterior angle is equal to its interior opposite angle. This is the interior angle. Leave this opposite angle, this one. So angle X if I Name the exterior angles you see in this figure. Name the exterior angles. Is B and yeah, tell me. Name the exterior angles.
Ma'am, C plus Y is equal to A, ma'am.
No. Please take my question correctly. Name the exterior angles found in this figure.
Ma'am, A, M, N and X.
A, M,
N and X, ma'am.
N and X. Exactly. A, M, N and X are the 4 exterior angles. You can get many more. In this figure you find, here in the figure you find 4 exterior angles, A, M, N and X. Now for angle, 1 second children. A, M, A, M, N and X are the 4 exterior angles. Now, which is the angle, which is the interior angle? For the exterior angle A, which is the interior angle? For the exterior angle A, which is the interior angle?
Angle C and angle Y.
Which is the interior angle?
Angle B, ma'am.
Angle B, ma'am.
Angle B. Now, the angle diagonally opposite to B is?
Angle C.
Y.
Angle C. Diagonally opposite. The angle diagonally opposite to B is C. A is equal to C. Exterior angle is equal to its interior opposite angle. Opposite is the diagonally opposite angle. B and Y, not B and Y, diagonally opposite, B and C. I repeat, A is an exterior angle, B is its interior angle. Interior opposite angle. The angle opposite to B, diagonally opposite to B is C. So the result is angle A is equal to angle C. Exterior angle A is equal to the interior opposite angle C. Now for the exterior angle X, children, which is the interior angle? Which is the interior angle for X?
Y, ma'am.
Y. Class, are we following?
Yes, ma'am.
Okay, Y. Now, which is the angle diagonally opposite to Y?
Z, ma'am.
Z. So what is the result we have? X is equal to?
Z.
X is equal to Y. Sorry, X is equal to Z. Exterior angle X is equal to the interior opposite angle Z. Now tell me N is equal to, tell me the answer straight away. N is equal to?
Y.
B, ma'am.
B.
E, ma'am.
N is equal to B. N is equal to B. What about M?
Y, ma'am.
M is equal to Y. Identify the interior angle and see the angle diagonally opposite to the interior angle. Now for M, for M, this is the exterior angle. This is the interior angle. Interior opposite angle, Y. So M is equal to Y. N is an now why is N an exterior angle? Because the side BC is produced. The side BC is produced. When a side is produced, an exterior angle is formed. N is the exterior angle formed when the side BC is produced. N is equal to, for the exterior angle N, C is the interior angle. The angle opposite to C is B. is B. So N is equal to B. N is equal to B. The exterior angle A is formed because the side BA is produced. The side BA is produced. So the exterior angle A is formed. Its interior angle is B. Interior opposite angle is C. So A is equal to C. So we have seen two properties related to a cyclic quadrilateral. In a cyclic quadrilateral, opposite angles are supplementary. In a cyclic quadrilateral, opposite angles are supplementary. Also, in a cyclic quadrilateral, the exterior angle is equal to its interior opposite angle. See, if you now, for example, the side is produced and say angle 1 is formed, children. Angle 1. And supposing we number this 2. And okay, and this one is 3, children. Now tell me, what is angle 1 plus angle 2? What is angle 1 plus angle 2 equal to?
180 degrees.
180 degrees. Why?
Linear parallel.
parallax.
Linear paraxium. Very good. Linear paraxium. What is angle 2 plus 3 equal to?
180 degree.
180 degrees. Why?
Ma'am,
Opposite angles are
opposite
supplementary.
angles are supplementary.
Because we just understood that in a cyclic quadrilateral, opposite angles are supplementary. Now A is equal to B, right?
Yes, ma'am.
So can we equate angle 1 plus angle 2 is equal to angle 2 plus angle 3? Is this right?
Yes, ma'am.
Because what is 1 plus angle? What is angle 1 plus angle 2? 180.
180.
What is 2 plus 3? What is
180.
angle plus angle 3? 180. So angle 1 plus angle 2 is equal to angle 2 plus angle 3. 2 on either sides gets cancelled. So what is the result we have? Angle 1 is equal to angle 3. That proves the property. So we have the result angle 1 is equal to angle 3. Angle 1 exterior angle is equal to angle 3 interior opposite angle. So this implies angle 1 is equal to angle 3. Angle 1 plus angle 2 is equal to 180, linear pair axiom. Angle 2 plus angle 3 is equal to 180, property of a cyclic quadrilateral. Opposite angles are supplementary. Equating these two, we get 2 gets cancelled on both the sides. We have angle 1 is equal to angle 3, and that proves the exterior angle property. Take a screenshot of this one, children. So remember these two properties. In a cyclic quadrilateral, opposite angles are supplementary. Exterior angle is equal to its interior opposite angle. So from here, you must write in your book. Till here, I believe you can read and understand. Now from here, you please write in your notebook because it's completely new. This theorem, children, was explained in the last class. I want you to write this in your notebook. Take a screenshot now. Write this in your notebook. We'll So when you write it, you're going to recall the theorem and the proof once. We'll discuss the same again in the class tomorrow. Please take a screenshot. Complete this in your book. Yeah, complete this in your book, children. Please
Now,
write.
ma'am?
No. By tomorrow's class. By tomorrow's class,
Okay,
finish
ma'am.
this. Yeah. By tomorrow's class.
Ma'am,
Yes.
tomorrow evening also we have class, ma'am.
Yeah, that compensation class. I will discuss that tomorrow morning. Yes. I want to make a class to compensate. Let me check with you tomorrow. All of you tomorrow. No, I don't want to spend time discussing that now. That's what it is. We'll have that discussion at the end of tomorrow's class.
Okay, ma'am.
Yeah, if most of us agree, we'll go ahead with the class.
Okay, ma'am.
Yeah. I'm saying most of us because the meeting recording is also available. So if majority of us can go ahead with the class, we'll have it. Those who cannot take it up should make use of the recording. We'll see that tomorrow. So this theorem along with this source. So if you wish, so discuss with your parents also regarding writing all this in your notebook. So if your parents insist that, if it's in the book, then it's easy to revise. Because screenshots, you will not remember that you have it on your device. If it's in your book, when you open the book, you find all these contents, you can revise it. So please discuss that with your parents. And yeah, you can decide whether to write all this in your book or no, but from here you have to write. Write this in your notebook and this one and this. The figure I've again got it on the slide. You don't have to repeat the figure, children. It's not twice because I need it for the proof here. I've done it 2 times. Otherwise, this is the theorem. This is the theorem. What you see here, what you see here is a theorem. This is a statement given to prove the 3 figures. Continuation, the proof here. So since we need to look at the figure to write the proof, I've put the same picture here on this slide. You don't have to repeat the drawings. Done, children?
Completed.
Yeah. Please make sure that you finish writing this by the class tomorrow. Yeah?
Okay, ma'am.
Okay. Take a screenshot and complete this also. So here, angles in the same segment of a circle are equal. I'll explain that. Angle in a semicircle is a right angle. And the last one I'll tell you when I explain. Take a screenshot. Done, children. So you are expected to complete from here. From here. 1, 2, 3, and I just want a minute, children. I'll show you a different slide. Just copy the figures in your notebook. Let's get back. Children, I said I just need a minute. I'll just show you the questions I have here. Please draw the figure. Let it be big. Don't draw tiny ones. Not only the figure, write down the question on your notebook. We'll be solving these in today's class. Yeah. I'll be on mute for some time. So I don't want you to waste time. Take down these questions in your notebook now. Now.
Ma'am, completed, ma'am.
All right. Circle A, B on the circumference of the circle, center O, AOB, AOB. This is the angle subtended by the arc AB at the center. Arc AB subtends angle AOB at the center. The same arc AB. Choose some point. See, this is the arc AB. So don't choose the point on the arc. This is the remaining part of the circle. This arc is the remaining part of the circle. This arc is the remaining part of the circle. We are talking about the arc AB that subtends, and subtends meaning that makes angle AOB at the center. So we are talking about this arc AB. So the remaining part of the circle is this arc. This arc is the remaining part of the circle. Meaning here it's the minor arc AB, which is subtending angle AOB at the center. So the remaining part of the circle is the major arc AB. The major arc AB is the remaining part of the circle. Choose a point on the remaining part of the circle. Choose a point on the remaining part of the circle, P. Join A to P and B to P. Angle APB, angle APB, angle AOB is the angle subtended by arc AB at the center. Angle APB is the angle subtended by the same arc AB at the point P on the remaining part of the circle. This language must be understood first, only then we can proceed. Meaning the language in this theorem. I'm not talking about my language, I'm talking about the language in the theorem. The theorem says angle AOB. AOB, angle AOB is the angle made by this arc at the center. Agree, children? Understand that? Do we understand that? Please.
Ma'am, can you repeat?
Yeah. Circle, center O. AB is an arc. What kind of arc is AB? Is it a major arc or a minor arc?
Minor arc.
Minor arc.
Minor arc. Now when I join A to O and B to O, angle AOB is formed at the center, correct?
Yes, ma'am.
Now this angle AOB is subtended or is made by arc AB, minor arc AB at the center, correct? Minor arc AB. One of you should repeat this after me. Minor arc AB, not immediately after me, once I finish. Minor arc AB subtends angle AOB at the center. Please repeat.
Minor
Arc AB
substance O at the center.
subtends. Subtends.
AOB at
Yes, minor arc AB subtends angle
AOB at the center.
AOB at the center. Very good. Now let's take a point. That point P can be anywhere on the remaining part of the circle. Not that I should take it here only. I can take it here also. Point P on the remaining part of the circle. Which is the remaining part of the circle? Arc AB subtends AOB at the center, right? So leave that arc AB. The remaining part of the circle is the major arc. Yes or no? Do we understand the meaning of this phrase, remaining part of the circle? Do we understand what is meant by remaining part of the circle?
Yes, ma'am.
Other than the minor arc AB, the remaining part of the circle. This is the arc. This arc makes this angle at the center. Leave this arc. Other than this arc, this one is the remaining part of the circle. This is the remaining part of the circle. We take a point P on the remaining part of the circle. Join A to P and B to P to identify this angle, which is subtended by the same arc AB at the point P on the remaining part of the circle. Now, if you have to repeat after I complete, angle APB is the angle subtended by the minor arc AB at the point P on the remaining part of the circle. Let me repeat. Listen carefully. Angle APB is the angle subtended by minor arc AB at the point P on the remaining part of the circle. So the theorem talks about the relationship between these two angles. There is an arc. It's like a story. You know, there is an arc. This arc makes an angle at the center. The same arc makes an angle at a point on the remaining part of the circle. What is the connection or what is the relation between these two angles? Or the theorem gives us the relationship between these two angles. The relationship between which two angles? The two angles made by the same arc. The theorem gives the relationship between two angles made by the same arc. Same arc. There is an arc. It makes an angle at the center. The same arc makes an angle at a point on the remaining part of the circle. Now, the relation between these two angles is that the angle formed at the center is double the angle formed on the circumference. So if this is x, this is 2x.
Yes, ma'am.
Thank you for acknowledging. See, thank you is not for understanding. If you don't understand, it's my duty to repeat. So I can repeat only if you say you have some doubt. Now, when you say repeat, you'll have to ask me what your doubt is specifically.
No doubt, ma'am.
Okay, Kanishka says no doubt. Others?
No doubt.
No doubt, ma'am.
Tarun, Hitesh, Ananya, Kanishka, Arav, Vasudevan, Nikita, Pranav, Shwani, Shreyas, and Tarun. Children, your microphone is the most important component for the online class. But I understand network, the internet, we are highly dependent on the internet. So when it's varying, you're not able to unmute and communicate, but that's really difficult.
Not that, ma'am.
No doubt.
No, ma'am.
I'm here wondering who did not understand.
No doubt.
Okay. That's what the theorem is. The angle subtended by an arc, the angle subtended by an arc at the center is double the angle subtended by the same arc at any point on the remaining part of the circle. The angle subtended. See, when I'm repeating, don't turn a deaf ear. This lady is, saying the same thing over and over again. Please listen. This should be registered in your mind. I'm repeating for your sake. The theorem, the statement goes like this. The angle subtended by an arc at the center is double the angle subtended by the same arc at any point on the remaining part of the circle. Okay, now let's take a point Q. Let's take a point Q on the remaining part of the circle. Join A to Q, join B to Q. See, we always to identify the angle, we always join the ends of the arc to that point on the circumference. We join the ends of the arc. AB is the arc. A and B are the ends of the arc. We pull A to Q and B to Q. So pull this. B to Q. I don't know if I can make it correctly, but let me try. Yeah. So this is the angle. This is the angle subtended by the same arc AB at a different point Q on the remaining part of the circle. So if this is 2x, this also is x only. Because the theorem, angle AOB, angle AQB, AQB, angle AOB, angle AQB. Who subtends AOB? AB at the center. Who subtends? Who makes this angle at the center? Arc AB. Who makes this angle on the circumference? Arc AB. The same arc AB makes AQB on the circumference. So in the center, if it is 2x, then on the circumference, it has to be x. Now, what do we understand from this? Angle, let me repeat this. Okay, let me finish it and then repeat it. So from this, what we understand is angle APB is equal to angle AQB. Now, when you join this, when you join AB, when you join the chord AB, you find that angle APB and angle AQB are angles formed in the major segment of the circle. Angle APB and angle AQB are the angles formed in the major segment of the circle, and they are equal. And that gives rise to the theorem, angles in the same segment of a circle are equal. Angles in the same segment of a circle are equal. Let me show you that. See the first one, angles in the same segment of a circle are equal. We'll do it again. Angles in the same segment of a circle are equal. We'll do that again. Let me clear the slide. Circle, center O, A, B. We are talking about this arc AB. We'll take point P, Q, R on the circumference. We'll join A to O, B to O. This is the angle made by arc AB at the center. Now we'll join A to P and B to P. So this angle is made by the same arc AB. See, you're joining, you can see here AP, BP. So the same arc AB subtends APB on the circumference, on the remaining part of the circle. Join AQ, join BQ. The same arc AB makes angle AQB on the circumference. join AR, join AR, join BR. So we see that angle APR, oh sorry, APB, angle AQB, and angle ARB. These three angles are made by the same arc AB at different points P, Q, and R on the remaining part of the circle. While this arc AB makes angle AOB at the center. This arc AB, this minor arc AB, makes angle AOB at the center. The same arc AB makes angle APB, AQB, ARB at three different points on the remaining part of the circle. Now, if the angle at the center, by the theorem, if the angle at the center is 2x, the angle at the center is double the angle on the circumference. So if this is 2x, then this will be x. Because that's a theorem. AB makes AOB at the center. The same arc AB makes AQB on the circumference. And the relationship between these two is center double the circumference. So x to x. Same thing, APB, AOB. When you compare angle AOB with APB, AQB, and angle ARB. These are the angles made on the circumference by the same arc. Center, circumference, center, circumference, center, circumference, center, circumference. And the relation is the center angle is double the angle on the circumference. So if this is 2x, this is x. So same thing here also it will be x, and here also it will be x. Now when you join this, you see the major segment. You see the major segment like this. You see the major segment, and in the major segment you have three angles. You have APB like this. You have AQB like this. You have AQB like this. And you have ARB like this. ARB like this. And you can see that each of them is equal to x. Angles in the same segment of a circle are equal. Angles in the same segment. So here you see these are, there can be any number of angles in the same segment. It's not restricted to 2 or 3, minimum 2, meaning when you have to say that this is equal to this, there should be 2 angles. So there can be, you can take many points on the circumference and find many more angles. So if you find 2 angles in the same segment of the circle, they are equal in magnitude. So this is what is angles in the same segment of a circle are equal. Again, angles in the same, if it's a minor segment, So supposing, let me draw like this. So now there's an angle formed like this here, and like this here. They're in the same segment, so this angle is equal to this angle. They're in the same segment. There's the minor segment, they're equal because they're in the same segment. See it? Minor segment. This is the major segment. This is a major segment. This is the minor segment. Take 2 points. Now let's call this P and Q. Take 2 points, R and S. Join P, R, Q and PSQ. Now this angle PRQ is equal to this angle PSQ because they're the 2 angles in the same segment of the circle. See, when we say same segment of the circle, the angles must be formed on the circumference, not inside the circle like this. See, like if it's just telling you, like not for such angles, not like this, somewhere like this. Now these 2 angles are not equal. You cannot say anything about these angles. We're not talking about such figures. The angles, the point R and S should be on the circumference of the circle. Angles in the same segment of a circle are equal. This angle RPRS is equal to PSQ. So we only see this angle is equal to this angle. Angles in the same segment of a circle are equal. Angle in a semicircle is a right angle. Angle in a semicircle is a right angle. Let's see that. Semicircle, no? So we have to take up the diameter. Semicircle, so we have to take up the diameter. Now each of this is a semicircle. This arc is a semicircle. This arc is a semicircle. And this arc is also a semicircle. This arc is also a semicircle. This arc is a semicircle. This arc is also a semicircle. Now angle in a semicircle is a right angle. This is a semicircular region. This one is a semicircular region. This one is also a semicircular region. Now choose any point on the circumference. We call it P. Join A to P. This is a semicircle. This is a semicircle. Join the ends of the arc. It's an arc. No, semicircle is an arc. Join the ends of the arc to the point P. So A to P and B to P. This angle. This angle. This angle is 90 degrees. Why? Because this angle is 180 degrees. Because this is 180. So it's half of 180, 90. By the theorem, angle at the center is double the angle on the circumference. So if the center angle is 180 degrees, on the circumference it will be half of 180, which is 90. And when is this 180 degrees? Only when AB is the diameter. When is this 180? It's not always 180. Only when AB is the diameter. When AB is the diameter, this angle is 180 degrees. So the angle at the center is 180 degrees. So on the circumference made by the same arcs here, AB is the arc. Arc AB subtends angle AOB at the center. Subtends angle AOB at the center. The same arc AB subtends angle APB on the circumference. APB on the circumference. Angle at the center is double the angle on the circumference. So if this is 180, this is 90. On the circumference, it is less. Circumference will be less than the center angle. Is it explained, children? Angle in a semicircle is a right angle. Have I explained that? Kindly respond, children.
Yes, ma'am.
Shreya says yes. Tarun, Hitesh, Ananya. Class, use the emoji. Raise your hand. Kanishka, Ananya, Shreyas, Vasudevan, Nikita, Shivani, Shri, Hitesh, Tarun. Arav, are you there?
Ma'am, I'm unable to use it, ma'am.
Okay. Arav and Pranav Rajan. Thank you, class. Okay. Please ask me if you don't understand something somewhere, please ask me.
No doubt, ma'am.
All right. The first and second one, angles in the, so this is the main theorem. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Theorem 1, angles in the same segment of a circle are equal. 2, angle in a semicircle is a right angle. 3, and then we also know some properties of a cyclic quadrilateral. In a cyclic quadrilateral, opposite angles are supplementary. Exterior angle is equal to interior opposite angle. So we need to keep all this in mind when you have to solve a numerical or a figure-based question. So some angles are given, you're given a figure, and some angles are given to you. You need to find some other angles. All these theorems should rush in. You should get all the theorems in your mind. Okay, now the last one. If a line segment joining 2 points if a line segment joining 2 points, so can you see it? If a line segment joining 2 points obtains equal angles at 2 other points lying on the same side of the line containing the line segment, the 4 points lie on a circle. So what is this? Okay. Now, line segment. 2 points A and B. Now this line segment subtends 2 other angles on the same side of it. So choose 2 points P and Q. Now A, P, Q. See, to make out the angle, join like this. Line segment AB subtends angle APB at P. Line segment AB subtends angle AQB at Q. Now in this case, the 4 points will be concyclic. The 4 points will be concyclic. That is, you can draw, such that these 2 angles are equal. Such that these 2 angles are equal. If a line segment containing 2 points subtends equal angles at 2 of the points lying on the same side of it, then the 4 points are said to be concyclic. Subtends equal angles. That means these 2 angles must be equal. If these 2 angles are equal, then the 4 points are said to be concyclic. I'll tell you again. Line segment. The 2 endpoints are A and B. Same side, so it should be above the line segment or below the line segment. On the same side, so it should be above or below the line segment. So let's say above the line segment. We'll take 2 points P and Q. Now the line segment AB makes angle APB, subtends angle APB at P. The same line segment subtends angle AQB at Q. And if these 2 angles are equal, if it subtends equal angles, if the line segment subtends equal angles at 2 other points on the same side of it, then so now what is it we have? We have a line segment. The 2 endpoints are A and B. It subtends equal angles APB and AQB at the points P and Q lying on the same side of AB. If all this is available to you, then this means that the 4 points are concyclic. That is, you can draw a circle passing through. You can draw a circle passing through the 4 points A, P, Q, and B. Now, when you draw the circle, it becomes more clear. Angles in the same segment of a circle are equal. So if 2 such angles are equal, you can draw a circle passing through them. So that's the theorem. Supposing we have 2 points M and N. We have 2 points M and N. And this is the line segment joining the 2 points M and N. Now this line segment MN subtends 2 other angles at the points, say P and Q. such that MPN is equal to MQN. MPN is equal to NQN. If the line segment MN, when it is line segment MN, already there are 2 points there, M and N. When this line segment MN subtends two equal angles, so MPN, MQN are the two angles, and supposing they are equal, if MPN is equal to MQN, both the angles must lie on the same side of it. So it's below, both of them are below. If these two angles are equal, then the 4 points are concyclic. Now I don't know if I can draw a circle, but then the 4 points are said to be concyclic. Just ignore it. Like this. So we'll repeat this often when we solve numericals, then it should become clear. If a line segment joining 2 points subtends equal angles at two other points lying on the same side of the line containing the line segment, on the same side, then the 4 points lie on a circle. That is, the 4 points are concyclic. So the theorems known to us: angle at the center double the angle at the circumference. Angle in a semicircle is a right angle. Angles in the same segment of a circle are equal. Then the properties of a cyclic quadrilateral. Let's use all this knowledge to solve these numericals. In the given figure, O is the center of the circle. If angle BAC is 48 degrees, so BAC is 48 degrees. Find angle BOC. Who can tell me the measure of angle BOC?
Ma'am, 24.
Kanishka?
Ma'am, 96.
96. 96.
Sorry, ma'am.
Yeah, 96. And what about angle OBC? OBC, this angle? Is this side equal to this side in triangle OBC?
Ma'am,
In,
yes,
in
ma'am.
triangle OBC, is OB equal to OC? In triangle
Ma'am,
OBC,
yes, ma'am.
why?
Ma'am, O is the center of.
Why is OB equal to OC? Why is OB equal to OC, children? Even I don't know. I'm going to wait for the answer from you. Think and tell me. Why is OB? See, when the question is why is OB equal to OC, that means OB is equal to OC. Why? Please rectify your microphones. Make sure that you can communicate in the class, children.
Ma'am?
Yeah.
Ma'am, because OB and OC are radii.
Hitesh, why you did not speak out any time earlier?
Ma'am, my mic was not proper. Now only it was rectified.
Okay, fine. All right, children. Yeah, Hitesh, you're right. OB and OC are the radii of the circle, so they're equal. So Hitesh, what kind of triangle is OBC?
Isosceles triangle, ma'am.
It's an isosceles triangle. Now, which are the equal angles in this triangle? Name the equal angles. Angle
Angle OBC and OCB, ma'am.
These two are equal. So by angle sum property, 96 plus x is equal to 180. Correct, Kanishka? Is
Yes,
this right?
ma'am.
96 plus x is equal to 180. Why x plus x? Because OB is equal to OC. OBC is an isosceles triangle because OB is equal to OC. OB is equal to OC because radii of the same circle. That makes OBC an isosceles triangle. Isosceles triangle property, angles opposite to equal sides are equal. Angles opposite to equal sides are equal. So opposite to this side is this angle. Opposite to this side is this angle. These two angles are equal. So now by using the angle sum property of a triangle, 96 plus x is equal to 180. 2x is equal to 180 minus 96. 2x is equal to, how much is this here? How much is it?
42, ma'am.
No, 180 minus 96.
It will be 84, I think.
84, okay. So x is equal to?
42.
Yeah, thank you. So x is 42 degrees, which means OBC is 42 degrees. Children, I couldn't prepare the answer slide. I just made the questions. So I'll show you now. We'll just understand in today's class. I think tomorrow I don't have time. So I'll show you the, okay, let me do one thing. Okay, I'll somehow share the answers with you on WhatsApp, children. So you can write out, you should write whatever we finished in today's class should be ready in your notebook by tomorrow's class. Don't forget. Maybe you should complete that and send your notes before tomorrow's session. Yeah, we'll do that. So we've discussed the first one. We have discussed the first one. Let's again understand the whole thing. Let's do it again, children. This angle is given to be 48 degrees. Which arc makes BAC on the circumference? Yes. Louder. Oh, that's difficult when the mic. I'm not so smart to understand this. Seriously. I don't understand.
Ma'am, you want to send this first one alone, ma'am?
No, darling, not the first one alone. Okay, I'll tell you. I'll message in the group, children. Okay. I'll tell you
Okay,
what all.
ma'am.
Yeah. All the theorems. Let me show you. Pranav Rajan. I'll show you now. See. Pranav. From here, Pranav, this one, this, and this.
No, that's not me.
Oh, who was that? Sorry. Tarun, is it? Okay, children, see, you'll have to complete this one from here. 1, 2, 3, 4. These. And all the numericals we discuss in today's class. By tomorrow's class, we finish it.
Then what about the introduction, ma'am?
Who's this?
Kanishka, ma'am. Do you want to send that also, ma'am?
No, not that. 1 minute, 1 minute. See, children, this one, these screenshots. I don't know, it's difficult to say don't write, but if you have time, please write. I feel if you're writing, you're just going to blindly write it. You're not going to really understand what you're writing. So I want you to understand. I think that can happen through reading. If you can Understand, you can read, give it one reading and then write it out also is fine. This is optional. All these. Reading that should do. Don't spend time on something else. You can just read once. Understand. From here, start writing. Again, I told you, ask your parents also.
Okay, ma'am.
Yeah, from here you need to write and submit. But if you have Kanishka, if
Okay.
you're going to write all this, you can take all the pictures and send it to me.
Okay, ma'am.
Yeah. Children, my question was, which angle subtends BAC on the circumference? Oh, sorry, which arc? Which arc subtends angle BAC on the circumference? Quick.
BC, ma'am.
Arc
BC.
BC. Is BC the minor arc or major arc?
Minor arc, ma'am.
Minor arc, ma'am.
Minor arc BC. Minor arc BC. Minor arc BC makes this angle BAC on the circumference at A. See, BC is the arc. It's not making the angle on itself. It's making the angle on the remaining part of the circle at A. The same arc BC makes an angle at the center, right? The same arc BC, BOC at the center it makes. It makes the angle BOC at the center. See, from the name you can make out BOC, BAC. Arc is BC. Arc BC, CB, both are the same. Arc BC, arc CB, both are the same arc. Refers to the same arc BC. So see here, arc BC makes angle BOC at the center. The same arc BC makes angle BAC on the circumference. And the relationship is the angle at the center is double. This is 48 degrees. This one is 96 degrees. How do we present that? You must say angle. Just write the relationship. The angle at the center is double the angle on the circumference. Just write the relationship. BOC is equal to twice BAC. Now substitute in the right places. How much is BOC? We don't know. Is equal to 2 into how much is BAC? 48 degrees. So angle BOC is equal. Just write the relationship. Just write the relationship between the angles. See, what do you know? We know the angle at the center BOC is twice the angle on the circumference BAC. This is the relationship. Always write this. If it's about these two angles, always write this rule. Now, supposing angle BOC is given, like it's given to be say 120. 120 is equal to 2 into angle BAC. So angle BAC is equal to 120 by 2. Understand a different situation. BAC is equal to 60 degrees. Just write this rule and substitute accordingly in the appropriate place. OBC is an isosceles triangle because OB is equal to OC. Opposite to OC is this angle. Opposite to OB is this angle. They are equal by isosceles triangle property. 96 plus x is equal to 180. And with the help of this, we can find angle OBC. Is it very clear, children? Is it clear or very clear?
Clear, ma'am.
Clear, not very clear. Then what's your doubt, Shreyas? Okay, maybe your practice will make it more clear. Fine. Children, the second one. In the given figure, O is the center of the circle. And angle AOC is 120 degrees. It's marked there, you can see. Okay. Find angle APC and angle ABC. Say true or false. Say true or false, okay? True or false?
True, ma'am.
Very good. Was it Shreyas? Yes, all of you share your opinion.
False because the circle does not pass through the point.
Yeah, Shreyas, think about that. Think again. Is AOCD a cyclic quadrilateral?
No, ma'am. The point O does not fall on the circle.
Yeah. AOCB is a quadrilateral. It's a quadrilateral. It's not a cyclic quadrilateral because of the four vertices, only three vertices A, B, and C lie on the circle. The fourth one, O, does not pass through the circle. It's the center of the circle. So AOCB is not a cyclic quadrilateral because all the four vertices does not fall on the circle. Identify a cyclic quadrilateral from this figure.
Ma'am,
Identify-
APCB.
A,
Ma'am, APCB, ma'am.
CB, APCB. A, P, C, B, all on the circle. So this one APCB, this one is a cyclic quadrilateral. All right. So we have to find APC, children. What is the measure of APC? What is the measure of APC?
60.
60 degrees. 60 degrees. Just write that rule. Angle AOC is equal to twice angle APC. Because AOC is made by AC at the center O. APC is made by the same arc AC at the point P on the circumference. So 120 degrees is equal to 2 into APC. So angle APC is equal to 120 divided by 2, 60 degrees. Please use the property of a cyclic quadrilateral and tell me what's the measure of angle ABC?
120 because opposite angles of a cyclic quadrilateral are supplementary.
Very good. Angle ABC is 120 degrees. 120 degrees. Ignore this one. Ignore this. Yeah. Ignore this. So this one APCB is a cyclic quadrilateral. Opposite angles are supplementary. This one is 60 degrees. So this one has to be 120 degrees. This one is 60. Opposite angles are supplementary. So this is 120. Also, how much is this angle, children? This is called the reflex of angle AOC. Angle AOC is equal to 120 degrees. Reflex of angle AOC is equal to 360 minus 120. How much is that? 240. So how much is this? 240 degrees. 240 degrees. So the major arc APC See the direction of the arc, like this it goes like this. Subtends, see the direction of the angle, like this, it goes the same way. See, this is the smaller version, this is the actual version. This one is a smaller version of the arc, this is the actual version. So this major arc AC subtends angle 240 degrees at the center. So this is the remaining part of the circle. This is the remaining part of the circle. This is the major arc. So the minor arc is the remaining part of the circle. So the same arc AC subtends this angle on the circumference. This angle on the circumference. This arc. This is the remaining part of the circle. B is the remaining part of the circle. Subtends this angle on the remaining part of the circle. So if this is 240, this will be 120. This is another way of finding out. If this is 240, the angle in the center is 240. On the circumference will be half of it, 120. This one is 60 degrees. This is 240 made by this arc at the center. This arc makes this angle at the center, 240 degrees. So this is the remaining part of the circle. This is the remaining part of the circle. This is the point of the remaining part of the circle. Join the ends of the arc. So this angle is subtended by this major arc on the remaining part of the circle. So if the angle at the center is 240, this will be half of it, 120. So the relation is always between this angle and this angle, this angle and this angle. If it's the minor arc, you will see the figure like this. Like this. It's a major arc. Sorry. The relation, look at these two figures, this one and this one. So the theorem is applied to this angle and this angle, meaning the theorem brings the relationship between this angle and this angle. In the case of a minor arc, this is double this angle. In the case of a major arc, the theorem brings a relation between this angle and this angle. This angle at the center and this angle on the circumference. This angle at the center and this angle on the circumference. So we said this one is APC 60 degrees by the theorem. And then you can find this one 240. And again, by the same theorem, you can say that ABC is half of 240, 120 degrees. This is one way of working. Otherwise, you can use the property of the cyclic quadrilateral. Opposite angle is supplementary. So this is 120 degrees. Is it clear, children? Class, use the emoji, lower your hands. Lower your hand and raise your hand again. Please lower your hands and raise your hand again. Nikita, are you there? Okay. Nikita, Shivani, Shreyas, Hitesh, Arav. Arav is there, but I called out Arav. You did not respond. Ananya, Kanishka, Vasudevan, and Tarun. All right, class, was it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right, children. So much you should complete writing in your notebook by tomorrow's class. Share the pictures. Before you take up tomorrow's class, share the pictures on WhatsApp. I'll also make the list. I think for the last 2-3 classes, I was unable to put up the list of the students who have completed or submitted their classwork. Excuse me for that. I'll do it from today. So this work which I announced must be completed before tomorrow's class, and you should submit your work before tomorrow's class. I'll announce the list on WhatsApp, plus I'll read out the students' names in the class. All right, children, that's it for this session.
Send it in the WhatsApp, ma'am.
Tarun?
Ma'am, what we want to write, you can send it in the WhatsApp, ma'am, because my screenshot is very blurry, ma'am.
No, you should not send the screenshots. You should write in the notebook and send what you write.
Okay, ma'am.
All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you.